Hello, everyone. Just getting started over here. Hi, Jonathan. Hello to everyone who's joining up. So the way this is going to work is I like to have very interactive workshops. So welcome to this one. My name is Ted Young. I'm one of the founders of the OpenTelemetry project. I work at Lightstep. And this workshop is going to cover getting started with OpenTelemetry in Java. So just the basic background on OpenTelemetry and distributed tracing, plus a code walkthrough talking about how to boot up OpenTelemetry, how to use the basic API commands, and how to integrate it with Java Spring specifically. So we'll have a Spring example at the end. But I love to know why people have shown up at this workshop. If people wouldn't mind just saying hi in the chat. By the way, when you're chatting, there's a to button, and I think it defaults to saying two panelists. I'm going to change that to two panelists and attendees. I'm going to do that right now and just say hi in the chat. So if people wouldn't mind just typing in a quick one-liner about why it is that they came to the session or what they're hoping to get out of it, I'm happy to tailor it to your needs. And we'll wait until about 11:10 to actually kick it off, since people tend to start a little late. But in the meantime, you can grab some of the goods that we're going to be going over. Here, let me see if I can shrink some of these panels. You guys can't see it, but Zoom has so many little panels over my screen. It can be a little hard to see them all. But first and foremost, I have the slides. You are all welcome to have access to these slides yourself, so you can take them away when you leave. And the code that we're going to be going over here is this repo that I maintain called OpenTelemetry Java Basics. So you'll walk away with this as well. And inside this code, you'll find a lot of annotations. So it's a great place to sort of copy paste OpenTelemetry API commands from if you forget how they work. So that's the link to the OTel Java Basics repo. And my one request is, in order to actually go through this walkthrough yourself, you need to have a backend to send the OpenTelemetry data to. These workshops use Lightstep as a backend. And so you'll find both in the slides and in the basics an opportunity to get a free Lightstep developer account. So if you don't actually have an account with Lightstep yet, my request is right now to go here and actually just create an account real quick. So give you guys that link directly. And it's really easy. Just put in your email, your name, you'll get an account immediately. And this is just a free account that lets you play around with OpenTelemetry data. So that'll be useful. You'll be able to get something that looks like this and be able to actually look at some of your data once it comes in. So you're welcome to follow along or just watch me do it and then try it yourself after the workshop. And this workshop is going to be recorded, so you'll have access to the video as well when we're done. Oh, and we're getting some good answers here in the chat. So hi, everyone. Bharath, hope I'm pronouncing your name right, says, trying to get more familiar with OpenTelemetry. That's great. You definitely came to the right place. A. Fisher says he's looking to, or they are looking to understand more about OTel as opposed to previous instrumentation libraries, also better understanding the concept of launchers at Lightstep. Great. Yeah, we'll cover both of those things. Glad you can get access to the slides, Jonathan. And Sudeep says, hi, I've been wanting to integrate distributed tracing for a long time. Finally got the go-ahead to do a prototype. Awesome. Have room for super noob questions, having started this 2 or 3 days back. That's perfect. This is definitely an introductory talk, and you will walk away from this both with an understanding of the basics of getting this set up for Java, and then also some tips at the end about how to actually roll this out in your organization. So thanks for all of that. And looks like we've got a stable number of attendees, so we can probably kick it off. If I do see more people showing up, I might stop and say hi to them as well. So one of the ways I like to do this is I like it to be interactive. So feel free to post questions either in the chat, or there's a Q&A tool you'll notice in your Zoom bar down at the bottom tool that says Q&A. So either the chat or the Q&A, feel free to post questions as we go. And then we'll take breaks between some of the sections, and I'll actually be able to unmute you all during that time so you can ask questions without having to type them out. That can make it a little easier, more interactive. Cool. And Mark says, interested to see how you manually instrument the code and apply relationships between traces spans without having static function calls all throughout the code base. It makes it difficult to unit test things. Interesting question. Interested to see how to correlate traces and spans when they go from one server to another. Great. Yeah, we will be covering all of that good stuff. And I see a couple more people just joined. So hello to the newcomers. So just to repeat it from them, you can ask questions in the chat. Please say hi in the chat. Make sure you set the to both panelists and attendees so that everyone else can see your comments. And if you wouldn't mind just saying hi and giving me a one-liner there for why you're interested in this talk. And I'm going to just repost some of these links again, because Zoom is kind of crappy in the sense that it doesn't preserve the chat history. So for the newcomers, here are these slides. Here is the code for the walkthrough you can take away. And then last but not least, if you wouldn't mind just right now, really quickly, just signing up for an account so that you have one, so that you'll be able to walk through this stuff. So let's do that thing. So that helps me help you guys. And Mark also writes, curious about the pros and cons of manual instrumentation versus auto instrumentation. Great. Yeah, we actually blend those two together. So I'll show you how to mix them both up in your code base and why you want to use one versus the other. But the answer is you want to use both. So let's get started since it's 11:10. So just a quick time check. We're going to start with just an overview of OpenTelemetry, do that for about 30 minutes, and then we'll switch to looking at actual Java code after that. And then at the very end, we'll pivot back to slides and talking about advice on how to actually roll OpenTelemetry out and roll observability out in your organization. Because I think there's some definite do's and don'ts and some potholes you can get into because you have to kind of organize your entire organization to adopt something like OpenTelemetry in order for distributed tracing to work. So with that, let's get started. So I'm going to leave the slides not in presentation mode just so that I can continue to see your chats. But a good way to get started talking about OpenTelemetry is the word itself. Like, why did we choose to call it OpenTelemetry versus something else? And the term telemetry means the science or process of collecting information about objects that are far away and sending that information somewhere electronically. That's a great definition for the part of observability that OpenTelemetry represents. It's about generating data, generating observations, and then transmitting those observations somewhere for you to then process them and analyze them. So it's not the processing and analyzing part, it's just the creation of that data. And the reason for that is we want to standardize how we observe our systems. Right now, all of that stuff is kind of glued together within a particular system, so it's hard to standardize, but we want to come up with a common language so that eventually systems can start becoming self-describing. The ultimate goal of OpenTelemetry is that you won't have to install an agent or an APM or anything like that. The open source software that you use will hopefully just come with OpenTelemetry and observability baked into it. And I one day hope to see a future where, right now, no one would want to use a library that didn't have any tests, I hope. And in the future, I'm hoping people will apply the same standards to production observability. You want to use libraries and software that not only is tested, but also provides you the data that you need when you can. Someone's saying, you speak about a slide that is not displayed. Can you all not see the definition of telemetry on your screen? I am screen sharing. Someone say yes or no whether they can see the slides. Okay. They're saying we see slide number 1. Weird. So when I go through these slides, you don't see your screen changing? Okay. Now it's working. Okay, good. So anyways, that's the point of telemetry. We want to standardize telemetry. Yeah, you got to look at my version. That's why it's not moving. So you want to have standardized telemetry. Ultimately, that's the ultimate goal. We're not there yet. We're just currently creating a system that is neutral enough and well adopted enough that eventually it could become a standard. So that's the goal of the project. And with that, let's dive into the big pieces that OpenTelemetry is made up of. There's several different components, and it's useful to just understand what these components are and maybe a little bit of why they're broken out. So the first component is what we call the SDK. So this green circle here represents your service. And in order to get telemetry out of your service, you need to install a client of some kind. So the OpenTelemetry client we refer to as the SDK. So that's the implementation that you install. And the SDK includes, it's sort of like a framework. So it's configurable, it has plugins and lifecycle hooks, and that allows it to be configured to talk to a number of different backends. So when you set up OpenTelemetry, the first step is to set this SDK up. And in Java, we tend to take the Java agent approach. So you attach a Java agent and that'll install the SDK for you. But you can also install the SDK manually if you want to. So you have options there. But the SDK is just something that's managing the life cycle of kind of setting up observability. And then when your system is closing down, when you're exiting the program, closing down OpenTelemetry and sending the final data off before the program exits. You don't actually mess with the SDK in your code or anywhere else where you're actually trying to record data. When you want to record data, you instead use the OpenTelemetry API. And the API packages, they're very lightweight packages. They just contain the interfaces that you would need to do observability. So things like logging, creating spans and traces, stuff like that. And the reason why we keep these separate is so that this API can become embedded in programs without hauling in a huge dependency chain. So the SDK might include dependencies like gRPC and all that implementation stuff, but those dependencies vary depending on what kind of SDK plugins you're installing. But just adding the OpenTelemetry API to your code doesn't haul in any dependencies at all or really create any overhead. If you instrument a library or an application with the API and don't install the SDK, then it's just no ops. And so this separation is what allows third-party software like framework code or database clients or things like that to add observability to that piece of software, and allowing you as the application owner to then grab all of those pieces of software and then configure the SDK yourself. So I hope that makes a little bit of sense why we want to keep those separate. It's just because this API code gets sprinkled around through your program everywhere, just the same way logging does. So you could think of this separation sort of like Log4j, where you have an interface that you put everywhere, and then at application startup time, you're configuring where those logs are actually going to go. So when you're writing instrumentation, you'll be grabbing the API. If you're configuring OpenTelemetry at startup, you're going to be doing that with the SDK or through an agent in the case of Java. And I got some more slides just kind of going over what I just said. So with the API, you've got these other libraries in here, your framework, your HTTP client, your SQL client, and then those libraries take in those API calls, and that's how you instrument your code. Auto instrumentation, by the way, is exactly the same as manual instrumentation, except the agent is taking instrumentation packages for all of these pieces of software and just installing them for you automatically. The actual instrumentation that gets installed, though, is just vanilla Java code. So these frameworks and libraries are not instrumented any differently than how you might instrument your application. It's just that the agent is installing that instrumentation for you at application startup time. And so for that reason, you could also, if you really don't want to use an agent, you could manually install all of that instrumentation instead. But I think the agent makes that a lot easier. The other component is this thing down here called the collector. So everything we've talked about so far is the OpenTelemetry client and what's going on within your service. But the next piece is the actual telemetry pipeline of sending that data from your service to some kind of backend. So you can just send data directly to a backend from your application, but usually in larger deployments, you're going to want to move out a lot of that telemetry configuration and telemetry pipelining into a separate service. And so that service we call the collector. So the way the collector works is it's sort of like a telemetry processor. It can take in telemetry from a variety of formats and then produce telemetry in a variety of formats. So for example, let's say you're using Zipkin to store your traces and you're using Prometheus to store your metrics. Inside the collector, you could take in OpenTelemetry data and then tee it off to those two systems in the data formats that those systems understand. You can also use the collector to manipulate the data and process it on the way out. So it's a good place to do things like adding additional tags or attributes or modifying attributes to ensure that they match, say, what you're looking for in your dashboard. So by doing all of that work in a separate process rather than doing all of that configuration within your app, you also kind of decouple the configuration and control of your telemetry data plane from the configuration and control of your application. So if you want to make a change to say where that data is going or how that data is being processed, if you're doing all of that work in a collector, that means you just have to redeploy your collectors. You don't actually have to redeploy your application services. So that's really helpful to kind of move telemetry management away from the application developer having to keep track of all that stuff or having to make a code change and a redeploy just to update how their telemetry is working. Instead, the operator can control that by making configuration changes to the collector and then redeploying the collector. So by having this kind of two-stage process, you're able to leave your services in more of a vanilla state that are just sending default OpenTelemetry data, perhaps to a sidecar or to a locally running collector service, or something that's just running in your VPN or your local network. And then you can use these collectors to buffer data. So you can have tiered collectors if you want, if you have a very large deployment and you need to manage, say, buffering of this observability data to handle things like processes coming and going, backends being redeployed, things like that. So the collector is a really useful component to look into. So where this collector eventually sends data is to some kind of backend tool. We call these analysis tools, something that actually stores the data permanently and gives you some way of analyzing it, like looking it up. So Zipkin, Prometheus, Lightstep, all of these programs are things you use to analyze data. And OpenTelemetry itself does not ship with any kind of analysis tool or backend system. And the reason for that is analyzing the data is sort of where all of the competition is. That's where all of the novelty and innovation is going on. And that's great. We don't really want to standardize how you analyze data. We want to invent new, better ways of analyzing this data. What we want to standardize is the data itself, what the data actually is, the format that it's in, and how it's being sent. So OpenTelemetry doesn't include any backend specifically for that reason. Instead, we seek to be able to connect to any kind of existing backend. And I'm hoping this will kind of create a green field for new analysis tools. Because in the past, if you wanted to build a new system for analyzing telemetry data, you would have to rebuild all of this other stuff, right? You would have to rebuild all of the instrumentation plugins, all of the clients and all the different languages, the collector, all of these things just to get your analysis tool to work. And instead of having to do all of that work, you can now just build a new analysis tool. So I'm hoping to see a lot more interesting kind of analysis come as a result of OpenTelemetry. And in fact, you can look at the Grafana Tempo product as a good example of something that's a sort of post-OpenTelemetry project. Also, Jaeger is a tracing system, open source tracing system that was designed with OpenTelemetry in mind. And of course, Lightstep, where I work, is a proprietary product that costs money, but it's really, really good. And it's designed to work with all of this data, which means taking not just tracing data, but metrics and logs, like all of the different kinds of data that your system might produce, and analyzing it as a whole instead of piping it off into a bunch of separate systems that only look at one part of the data. This is kind of a complicated system, so one note on how the project is organized. The way we keep track of all of this stuff and keep it all kind of in lockstep and working together and synchronized is through a specification process. So we have something called the OpenTelemetry specification and a technical committee that's in charge of writing that specification. And so people make RFCs to the spec, they get approved, they get added to the spec, and then the maintainers of the different OpenTelemetry clients implement the latest version of the spec. Of course, those maintainers are also part of the process of creating the specification, so we get a nice feedback loop. But this is a totally open process, so if you do get involved in OpenTelemetry and you want to help move the project forwards, it is totally open. That means you can get involved with writing OpenTelemetry instrumentation or improving the Java agent, or even writing spec proposals if you want to see the project add a feature or go in a new direction. So you can go to the OpenTelemetry organization on GitHub and get more details there about how that works. Cool. So that was it for the initial phase of this workshop, just covering the various pieces of OpenTelemetry. We're going to dive into some basics around distributed tracing and some other core concepts like that. But before we do that, it would be good to know if there are any questions at this time. So you can either type a question out or I'm going to see if I can actually allow people to talk. So if you want to actually just ask a question verbally, use the raise your hand feature that you can find in the Zoom bar at the bottom. And then I'll be able to turn your mic on this side. And A.A. Fisher writes, there's confusion around the version of different parts of OTel. Can you elaborate? Yeah, it would be super great if we could just have one version number, like the spec is at 1.2, and then everything implements 1.2. But unfortunately, it's not really that simple. Every part of OpenTelemetry might need to make changes that are changes outside of the spec. For example, fixing a bug or doing something that's kind of language specific. So unfortunately, we aren't able to keep all of the version numbers in lockstep. Instead, the spec has one version number, and every component, the API, the SDK, the collector, they all have their own version numbers. I can actually give you some details about, if you go to the specification itself, there's a section called versioning that I wrote recently. So versioning and stability. So let me give you a link to that. And this document covers what kind of stability guarantees we will actually give, what kind of long-term support the project has, and how the version numbers actually work. So there's also just some graphics in here that'll show how it goes. I don't have time to fully go over all the details, but one thing you might want to know is once things are stable, we do offer long-term support. So for the API itself, there's a 3-year support guarantee. And for the plugins and the constructors, that's a 1-year support guarantee. So every time there's a major version bump of one of those components, you'll get at least a year's worth of support for the prior major version. And just to be clear, we actually have no plans on doing any breaking changes to the API once it's stable. So there is a theoretical 3-year support guarantee, but the plan is to not actually deprecate any of that stuff. And glad you like the graphics. It's me, the Tedster got his hands on a iPad tablet, so I've been drawing those things up. So this doc, if you want to get into the nitty gritty about what's actually being offered, you can see the current state of this by reading this doc. Cool. Any other questions at this time? You can raise your hand if you want to do it verbally. Otherwise, I'm going to move on to the next section. Cool. Well, I'm going to move on, but again, you can keep asking questions by posting into the chat. And I really do appreciate the questions and the feedback. I much prefer to answer questions than just talk. I see Bharath has a question. I'm going to allow you to talk. Bharath, how are you doing?
I'm doing well, thank you. How are you?
Doing great. How can I help you?
So I'm not sure if you can see my image, but I'm going to ask my question. So I was trying to see if the span ID or the trace ID, which probably you'll cover later, that is part of the tracing, can actually be used to correlate a workflow in a distributed microservices architecture. Even in the production for all scenarios. So as opposed to just having a specific period during which you would run tracing, is it beneficial to actually use the same request ID to correlate a workflow?
Yes, so you're saying like you have a sort of distributed transaction, you have a lot of moving pieces in your system, and you want to be able to correlate that entire transaction, right?
That's right. So my understanding is that when you actually, generally people enable distributed tracing only when they want to look at the performance or maybe have some metrics drawn from their system behavior. I was trying to see, instead of having multiple IDs generated in the system and having to maintain them over time, would it be beneficial to use the same ID for both purposes?
Yes, yes, you can. That's a very good point. Distributed tracing has kind of a weird history, and you're doing a great job of setting up this next section, by the way, because we're going to cover exactly this. Distributed tracing has this history of being just this niche thing that you would install just to do performance analysis. But that really is kind of a misnomer. And part of the reason it was bucketed like that was back in the day, distributed tracing tools tended to use a very simple form of sampling, which means you would just roll a 1024 sided dice, and if it comes up 1, then you would turn on tracing. And because it was just random sampling like that, it wasn't necessarily a great tool to use for logging and other features, because only a small fraction of the time would you have access to those IDs. With OpenTelemetry, it doesn't work like that anymore. So if you turn the tracing system on, it's on all the time, and the sampling actually occurs at kind of a data level. So we have a more nuanced approach to sampling that lets you have access to those IDs all the time, and then you can use those in your system. You can use those to say, correlate your logs and do other things. So it's definitely a more robust tool. OpenTelemetry itself also isn't just tracing, it's tracing plus metrics plus logging. And the metrics and the logging work on top of the tracing system to give you these higher quality correlations. And that's what we're going to get into right now. So let's do that. Thank you for the question, though. It's really good. So let's follow up on that. There was a question about transactions, and I want to just kind of clarify what a transaction is. I mean, you all know this, but just to be clear, when we say distributed transaction, we're not necessarily talking about something fancy, but this is what we mean by a transaction. So imagine you have a really simple app, and what it wants to do is upload a photo with a caption. So what does that look like? Well, there's a client, let's say it's a mobile client, and that thing sends the photo and the caption to a server. But we all know it's never that simple, right? Like that server is probably some kind of proxy of some kind. It then has to authenticate you, so it's talk to an auth server. Once that auth server says, yep, this is authenticated, then it might take the photo and write it down temporarily to scratch disk. It might then send that information on to a local app service. That app service might then process the image and upload it to permanent storage, let's say an S3 or some kind of cloud storage system. And then it takes the location of that image and the caption and stores that in a database, which is fronted by a data service. The data service takes that information and stores it in some kind of SQL database while caching it in Redis or Memcache or something like that. So this is what we mean by a distributed transaction. But if you've been around for a while, you might also notice this is like the most generic LAMP stack the world has ever seen. Like, I feel like I've been writing apps like this my entire, since like the late 90s, we've been doing these things. So it's actually always been a distributed system. It's just that our systems are now getting so complicated and potentially have so many services involved, or they're scaled up to the point that tools that don't correlate the information coming out of these systems make it really hard to actually see this graph of information. And the most basic thing I've always wanted to do is just get the logs, right? Like, let's say you want to see this particular transaction and you just want the logs for this one transaction. That has always been harder to do than one might think, because you have all of these different computers. And if some of these are like scaled up horizontally and they're all just writing logs down, if you want to find just the specific logs for this particular transaction, how do you do it, right? Like you have all of these logs, but you just want to find the logs that were part of this one transaction. And in order to do that, you need to have some kind of way to correlate all of the events. So as we hop from service to service, you need to have some kind of correlation that allows you to link up all of these logs together. And that's what distributed tracing gives you. It gives you an ability to see all of the data that was part of one transaction. And we'll go into the technical details of how that works in a minute, but just to let people have an understanding of what distributed tracing tends to look like, it tends to look like this. So one way to look at this system is to look at like a kind of service map, but this doesn't exactly tell you how much time was spent in each system or how these different systems are connected together. So if you start using distributed tracing tools, you'll start to see graphs that look like this. And so each color of the graph here matches the color of the service. And so we can see we have a client span here. So this is when the client started its transaction. And then this is when that transaction ends. And the arrows here represent network calls. So the client makes a call to the reverse proxy. The reverse proxy calls the auth service. And then after that, the reverse proxy writes the image down locally, and then it calls your app service. The app service calls S3, then data service, blah, blah, blah. So this kind of graph can show you a lot of information just at a glance. I tend to think of these as flame graphs if you ever used a flame graph tool. That's like another form of tracing. But it'll quickly tell you the relationship between things, how much time is spent there. And that'll give you a quick overview of what your system is doing. One thing you might want to figure out, though, is like, how do you optimize this system? And you might see that the client is taking too long, right? Let's say the end user gets bored after a certain amount of time and then hits cancel. So you're seeing that, when this client span takes too long, you're either timing out or the user's having a bad experience. But you can't just optimize the client, right? Most of the time is being spent somewhere else in the system. So one thing distributed tracing can give you off the bat is something we call the critical path, which is just identifying where the actual latency is occurring. So if you wanted to, say, go in and optimize this system, maybe you might try to optimize this data service over here. But if you look at this critical path, you can see that optimizing this data service isn't going to save you a lot of time, right? The majority of the time is actually going into image processing here and here. So it wouldn't actually be worth your time to go in and optimize this data service. You want to focus on optimizing the speed at which you're processing these images if you want to actually lower the overall latency. So that's the first handy tool that you can get out of distributed tracing. It also shows you sort of as a corollary where your system is sitting there and waiting, right? So you can see where the information is actually being processed, and you can see where services are sitting there idle, waiting for some other service or thread to process that information. And that can also be useful to identify concurrency issues, things where something is serialized or a system's tying up resources in a certain way. You can see that when you look at this critical path, because you can see that a certain process or system is sitting there blocked. So for systems where that blocking is a problem, that can be helpful as well. The other thing you, of course, want to know is if there's an error, where did that error originate, right? So you might record on your client that you got a 500 back and there was a problem, but you want to know where in this graph that problem originated. Did it come from is it an authentication error? Is it a problem with S3? Is it a problem with your database? Being able to quickly identify which service or operation created the problem is something that distributed tracing gives you out of the box. The next thing you might want is, of course, events. This gets back to my original proposition that it's hard to find all of your logs. We call logging events currently in OpenTelemetry. So whenever you have one of these spans, you can log events onto that span. And then those events are recorded into the trace, which means when you look at a trace of your transaction, you have all of the logs that are exactly associated with that transaction. And this completely eliminates this problem I was talking about here, where you're trying to dig through all of your logs in some manner in order to actually get the data that you want. You might find if you get done with this talk and go back to triaging production issues and looking at your logs, just notice how much time you're spending just trying to filter down to the logs that you need. And like that sort of mystery hunt of finding a bunch of different IDs or different ways to kind of filter this down just to get a view of this transaction, I have found that that actually takes a surprising amount of time. And using distributed tracing gives you that information instantaneously. And so that's a huge time saver when you're trying to debug a production system, right? Because you're not spending time collecting that information and filtering it and looking for it. You're just seeing the data and then trying to make decisions based off of that. So that's a big win for distributed tracing. And it's not just individual transactions that you can look at. Each of these spans has attributes on it that allow you to correlate these transactions with each other. So that's really helpful to know. For example, the host, regions, URLs, HTTP status codes, all of the information you might use in order to identify an error, including application information. For example, you might attach a project ID to one of these traces. And then let's say you're seeing errors in one of these systems, being able to automatically correlate that error with a project ID and noticing that, say this error is occurring across all projects, or noticing that you're seeing a lot of errors, but they're actually isolated to one or two particular project IDs. That would give you a pretty good hint to where to start looking for the problem. So being able to correlate across transactions is another powerful tool that you can do with distributed tracing. You can do this today with regular logging. It's just a lot more work. So what you get out of distributed tracing is just an elimination of the amount of work it takes to find this information and the potential to actually automate that work. So at Lightstep, for example, we automate this correlating. So the system will just tell you, hey, buddy, I'm noticing that these errors correlate highly with this particular attribute. That's information that might take you a while to figure out on your own. So it really boosts the speed of that firefighting process when you're trying to actually triage an issue and get to the bottom of it. Being able to automatically see these correlations and jump around through your traces. Once you get used to that approach to looking at your system, if you go back to systems that don't have distributed tracing as their underpinning, you're really going to realize how much time you are spending collecting that data. I kind of think about that like automatic code formatting. I didn't use automatic code formatting for a long time, didn't really think of it as an issue, but then I started using languages and tools that automatically formatted my code. And then going back to some system where that doesn't happen, suddenly I'm like, oh my God, I'm spending so much time like hitting tab or just messing around with this stuff. I just want to just hit save and have it just automatically format, not care about it. So distributed tracing gives you a similar feeling. Okay, so I'm going to stop there for a second and take some more questions. So Barth writes, will there be scenarios where events are distinguished from log messages? Yes, there are scenarios where events might be distinguished from log messages. Mainly, you might already have logging in your system, right? So if you're already logging using a traditional logging tool, those logs are not automatically going to become trace events, but it's usually fairly straightforward to write a log to trace converter that just says every time you call log for j, look to see if there's a current span. If there is one, add that log to the span. You can also go the other direction, which is every time you call log for j, if there's a current span, add the span and trace IDs to your logs so that in your existing logging tool, you'll get those IDs and can search around with them there. So you can actually tie your logging system, your existing logging system together with OpenTelemetry pretty easily. That's actually a good bootstrapping maneuver when you're just getting started with distributed tracing. It's an easy way to get your existing logs and just funnel them into your tracing system without having to do a lot of work. So I do recommend that. Also, theoretically, you might have logs that are outside of a transaction, say like application startup and stuff like that. Currently, we have a logging working group that's thinking about capturing those kinds of logs. So more questions here. How can the business value of distributed tracing over log analysis tools be explained to executive leadership? Time savings, like the ability to, time is money, right? So the ability to eliminate latency issues, if you have, if you can correlate the amount of time your system is spending with a loss of revenue. For example, like slow systems tend to be annoying to end users. So nobody likes a slow system. So being able to quickly, one quick win you can do is just look for latency issues along important or common code paths. And if you've never installed a distributed tracing tool, you might be surprised. Almost every system I've seen where you turn distributed tracing on for the first time, there's some kind of like low-hanging fruit that jumps out at you around like a latency issue that could be solved rather easily. You just weren't able to see it so clearly because you didn't have that timing information actually presented in a nice visual way. So that's really useful. The other thing you can point out is it allows you, when you're firefighting, to do your analysis much faster. Since you're no longer having to spend the time collecting and filtering down this information, you can move a lot faster going from one hypothesis to another, investigating your system. So that reduces downtime significantly. That's the other significant win people see when they move to distributed tracing. And next question is a high cardinality attribute like user ID a good or bad candidate for associating with the span? That depends on the analysis tool. Some analysis tools can handle high cardinality well, and other tools can't handle it so well. So that kind of just depends on how you're analyzing the data. But it's not automatically bad. In fact, even if you're not using something like user ID as an index because your system can't handle it, it still might be a useful attribute to put on the span anyways, just because it'll allow you to do a secondary investigation. So I would say don't worry about adding attributes that have high cardinality if it's information that you want. And of course, I'm going to plug Lightstep here. Like, we handle high cardinality very well. So if you're trying to actually index on high cardinality events and attributes, switching to something like Lightstep or an equivalent system that can handle high cardinality is a good idea. Cool. All right. So we're chugging along here. I'm gonna just quickly move through this context propagation section so that we have time to actually look over some code. And I'll take questions again when we get to the bottom of this. So context propagation, this is kind of the core to how distributed tracing works. We've been talking about these transaction IDs and span IDs and stuff. So I just want to take a moment to actually just go over the basics, fundamentals of how distributed tracing works. You don't necessarily need to know this stuff to use OpenTelemetry because the instrumentation that OpenTelemetry installs generally will install all this for you. But if you do have a problem with context propagation breaking, just understanding the fundamentals of what's happening there can help you solve it. So let's just go over that real quick. So the way distributed tracing works, let's just imagine you've got two services talking to each other, service A and service B. Service A, you have three operations, and then the third operation calls out to service B through a network call, and that thing performs a couple of operations before returning. So like that's a basic transaction. The way distributed tracing works is it tracks your workflow, and that has two parts. The first part is what we call context or context object. So the way context works, it differs by language, but in Java, it tends to be implemented through thread locals, sort of like MDC if you've ever used that. But basically a way of having a bag of information that actually follows your execution path as it goes and is always available. So this means you don't have to actually pass this context around by hand. It's being passed around in the background, either by a thread local or another implementation if you're using some kind of like userland scheduler. But that's set up by the SDK and is just generally available through your execution. And so then the tracing system takes a trace ID that it starts right here at the beginning, and it passes that around using the context. And then in each operation, it creates a span ID. So you have a trace ID for the entire transaction, and then a span ID for each operation in that transaction. And the context object is holding those IDs along with some other information and is passing it from operation to operation as your code executes. That's pretty normal. Where it becomes distributed is this part here where you have to hop from service A to service B. And we call that part propagation. So that's the propagation part of context propagation. And with HTTP, that's simple enough. What you do is you take that context, like that trace ID and that span ID, and you inject it as HTTP headers. So that context will get added as HTTP headers to your HTTP request. And if it's not an HTTP request, like let's say it's a Kafka queue, then it'll get added as Kafka metadata. So OpenTelemetry propagators can be configured to work with a variety of different network transports. But we call that injection. So you're taking your context and you're injecting it into whatever this carrier or network request is. Then on the server side, you have an extractor that attempts to extract that context from every incoming network request. So if these two are configured to use the same headers, then when you inject your trace ID and your span ID into HTTP headers here, this server will see those headers, extract those IDs, and make a new context object that then continues to follow your flow, and so on and so forth. So this fundamental of having a context that follows you and then automatically injecting and extracting that context is what allows you to pass around these correlating IDs. So you can generate a trace ID at the beginning and then have it accessible through your entire distributed system. So the tracing system will do that automatically. I should mention OpenTelemetry has a subsystem called baggage, which allows you to put any IDs in here. So you can use the baggage API, again, like let's take a project ID as an example. Let's say you have access to a project ID here. Rather than going and fetching that project ID in every operation that you want to attach the project ID to as an attribute, you could add that project ID as a baggage, and then it would flow through the system as well, and you would have access to it wherever. And you can use that for tracing, to add it as attributes to different spans. but it might just be a useful feature in general for your system. I actually expect people to build cool tools on top of baggage at some point. For example, things like A/B testing in a distributed system, knowing whether you're on the A path or the B path could be really helpful. Otherwise, trying to do A/B testing in a big distributed system becomes a little complicated, right? Like, how does the service that's like 3 tiers down know whether it's on the A path or the B path? So just passing that information around through baggage can help you there. Obviously, the more baggage and context you have, the more your headers are going to get bloated. So you don't want to just throw things in there without thinking. But out of the box, OpenTelemetry doesn't come with a lot of overhead. It's just a couple of headers, one containing like 128-bit ID, another one a 64-bit ID, and then a little bit of metadata beyond that. And those headers we're trying to get standardized through the W3C. So just real quick, the ones that actually exist today, we've added something to the HTTP spec called trace context. And that's these headers I was just talking about. Since your client and your server have to agree on what headers are being used, having official headers to do this in W3C really helps. So the trace context headers, one header is called trace parent, and that contains your trace ID, the span ID of the parent operation, and then a flag to let you know whether sampling is turned on or off. Then there's also another header called trace state. That is just where systems like OpenTelemetry can put a bunch of internal details. You don't have to worry about that too much. And then likewise, we have another set of headers called baggage headers, which are also being added to the W3C spec for HTTP. So that's in progress right now. So that's the basics of context propagation. Hopefully that makes sense. When you do set up OpenTelemetry, one thing that can go wrong is misconfiguring these headers. In addition to these W3C headers, Zipkin has a set of headers called B3 headers that are pretty common. So you want to just make sure you're not mixing and matching these headers when you set your system up. You want to make sure everything is configured to use the same headers. And if you're trying to integrate OpenTelemetry into an older system that's using B3, you could actually configure it to set both headers, W3C headers and B3 headers. A little bit of extra overhead, but that would allow you to do like a seamless transition. So hopefully that's kind of a fire hose of information, but hopefully it makes sense. Okay, we're going to stop for one more Q&A section here before getting into a code walkthrough. Bharath writes, embedded systems impose resource constraints, and this restricts usage of distributed tracing. What are recommendations of best practices, leverage distributed tracing in resource-constrained environments? Yeah, that's tough. Currently, there is no standard answer for that. But just so other people understand, if you have like, microcontrollers, or you're doing Internet of Things, or you have like a very, very lightweight protocol, then something like 128-bit trace ID might be just too heavyweight for that system, right? Like there are some messaging protocols where 128 bits is bigger than the entire message. And so unfortunately, at this time, OpenTelemetry doesn't have a standard answer to those questions. That is a thing people are interested in working on, though, which is tracing for Internet of Things and figuring out how to solve the issue of, say, reducing the overhead without reducing the amount of randomness. The problem is if you start chopping down the size of this trace ID, you're reducing the amount of randomness, and you're going to start to get collisions at some point, especially if you have a big system with lots of sensors. So that's sort of an edge case that hasn't been fully worked out yet at this point. And then there's a question, is there a roadmap to integrate cloud events with OpenTelemetry? Not to my knowledge. I am somewhat aware of cloud events. I think this is being used by Kubernetes in some fashion. And OpenTelemetry is getting integrated into Kubernetes as we speak. So I imagine there's a fairly straightforward way to integrate this information, but it's not something I've looked into myself. Oop, I just closed the chat window. One sec. Open that up again. Try and close that. So Mark asks, why would you need baggage when you're looking at the overall trace and something like Lightstep? Wouldn't you have the attribute values available to you as long as the span somewhere on the trace added it? Why does it need to be propagated? Yes, that's totally correct. You don't need to use baggage just for adding attributes to a particular span. It's more useful. This is sort of like a userland tool. So you may just find it useful in your system itself to propagate some information. So outside of just the observability aspects of it. So yeah, generally speaking, you don't need to add attributes into baggage. I think I gave that as an example. It's just not a great example. But I'm just pointing out that you might discover, for whatever reason, now that you have distributed tracing, it would be nice to have access to some ID further down the line in order to do something with it, or some other piece of information. So baggage is more, it's sort of like a non-observability version of distributed tracing, right? It's just saying, as long as you've set up context propagation, you're not just restricted to sending these particular IDs. If there's just other information you might want, you can send it around. So A/B testing is a good example of that. Authentication, authorization is like another one. I've seen people use this to pass around that kind of information. But that's sort of like undiscovered country. I expect when something like OpenTelemetry gets widely used, you're going to see some systems start to get built on top of that. And I really think A/B testing is the best example of that. I wouldn't be shocked to see people start adding A/B testing or feature flagging, things like that, as baggage to prevent you from having to like hand add those particular attributes to all of your network requests. So hopefully that answers that question. Okie doke. Let's do a code walkthrough. So I go here to OTel. So if you want to get started with OpenTelemetry in Java, we recommend using a Java agent. OpenTelemetry comes with a Java agent. So if we go to OpenTelemetry, it's actually not the OpenTelemetry Java is just the basics. And then if you look for Java auto instrumentation, this one, Java instrumentation, this is the Java agent. And you can find all the details about it here. But one thing a lot of vendors like Lightstep are doing is just taking these agents and these SDKs and wrapping them up in their own distributions. And that's just because when you go to configure these things, most of the configuration you're doing is about configuring it to talk to a specific backend. So rather than having to like add all of that configuration by hand and potentially mess some of it up, we provide something called the Lightstep launchers, which are just wrappers around OpenTelemetry that pre-configure everything to work with the Lightstep defaults. Amazon has one of these as well. So you'll notice there's a AWS distro for OpenTelemetry. It's the same deal. It's just pre-configured to talk using the X-ray format to like the standard X-ray endpoints. And Likewise, the Lightstep one is just pre-configured to talk to the standard Lightstep endpoints. Lightstep uses OpenTelemetry data natively, so you don't have to change formats. So it's a very lightweight wrapper. But just to let you know, that's what the wrappers do. So if you want to get started with one of these, let me show you how you would do that. So one example is to use, like, let's say Java Spring. So if you're using Spring, we can use this example app called Pet Clinic. You might have seen this app before. This is just standard sort of Spring app that lets you add and remove pets and owners and veterinarians and stuff. So we can take this app and we can wrap it up with OpenTelemetry. And so the way you do that is you just get the Spring Pet Clinic app, package it up with Maven, download our agent, and then you just need to configure it with a couple environment variables or Java properties, system properties. The two you need that are required to talk to Lightstep is the name for the service and then an access token. So if I'm here in Lightstep, I can go to settings and I can get my access token here. And then here I've gone through the prior steps and I've already exported the service name to be Pet Clinic and added my access token. So those are the two pieces of configuration you need to talk to Lightstep. And then once you've done that, you can just start your app using the Java agent flag pointing at the Lightstep agent. So let's do that. So that gets started, spews out a bunch of information. The JVM, so swift. Okay, so Pet Clinic started up. So if I go to localhost, here's Pet Clinic, and I can click around. Let's add an owner. So here's me with Lightstep's address put in. Add a pet. My cat's named Penny. Put Penny in here. Penny is a cat, not a bird. And then now if I go to find owners, I can see I'm listed here. And then I can take my cat and like add a visit. Description, gotta get his shots. Okay, so I've just been interacting with this app a bit. Oh, there's also a way to trigger an exception here. So here's some problems. Now I'm just gonna go look in Lightstep and have a look at the data that came in. So boom, just from interacting with that app, it's just been sending data to Lightstep. And we can see a lot of spans coming in. You notice some of them are red. Those are spans that had exceptions on them from triggering that error. Let's have a look at a trace. So here's a trace of Java Spring. Notice I haven't actually added any instrumentation by hand. So this is just the instrumentation you're getting out of the box that's being added to all of the various Spring components. So you can see the actual HTTP request here. You can see how much time was spent in the controller, how how much of that time in the controller was actually being spent in the database. So this is the repository. And then these are the different database calls that went on. And then you can see down here, we're rendering out the HTML. So you can see actually, because this is such a lightweight little app with the database running in memory, most of the time was actually spent rendering the page. So this would be helpful to instantly know out of the bat, well, if I wanted to make this faster, I would want to work on page rendering. We can also have a look here. If I click on this span that represents the route, and you can see all of this standard HTTP information being added here. So we have the method, the status code, all of that useful stuff, the URL. And then you can use these things as correlations. So I can just say, have a look here at this particular URL, and I can see all of the spans that came in on that. It looks like I only clicked on this once. So if I go here, go find owners, and just reload this page a whole bunch. And then rerun this query. Might take a second. Here we go. Now you can see all of the spans on all of the different traces that were for this particular URL. And then I can click into that one. And then maybe, you know, it's not particularly helpful, but I could look at like everything that had status code 200. Might be more useful to find everything that has status code 500. So here's all the different endpoints that return a 500 error. And then I can look into here. I can see where these errors actually occurred. And I can look down here at my events, and I can see the exception. We really got to render this better, guys, UI guys, if you can hear me. But you can see you've got the exception automatically added onto here. So that's sort of the basics of looking around at traces with distributed tracing. Lightstep has a bunch of other tools. This isn't a Lightstep workshop, so I'm not going to go into all the different tools. But I hope this gives you an example of like the kind of basic workflow of being able to just move around and look at these requests. And you'll notice just like how quickly I'm able to move around between these things. If you didn't have tracing and didn't have these correlations, it would take a lot more time just to gather this information up instead of just being able to kind of hop from place to place. So that's the basics. If you're just getting started with OpenTelemetry in Java and you're using like off-the-shelf open source libraries that are currently supported, you don't actually have to do any manual instrumentation yourself to get context propagation going and get a good amount of information out of your system. So that's sort of step one. We can now get into how might one want to add information yourself. So we'll do that next, but let me just answer a couple of questions in the meantime. So Mark writes, in the Explorer view in Lightstep, can you filter the list to just traces and not show every span? You know, we've been looking at adding these features, but I'm not sure that they've actually added that yet. But yeah, it would be helpful to be able to filter this down and just look at traces rather than not all the spans. Likewise, sometimes I want going the other direction. I want more like a log view of just like show me all of the events. So that would be a good feature request. Using Lightstep, should make that feature request. I would like to see it. Okay, feel free to keep posting questions. We're at 12:15, so I do want to just move on real quick and show how you would actually add this stuff by hand. So we're going to switch away from Spring and we're going to look at a simple client-server example. So the client in this case, all it does is it just makes 5 requests in a loop and then ends. And it makes a span around every request. And it makes a master span around all of the requests, or like a root span around all of the requests. Then on the server side, we just have a little Java servlet. And because HTTP servlet is part of OpenTelemetry's instrumentation, this automatically gets instrumented, but we can then add additional data on top of that. So let's start with this as a good example of how to add additional information. So most of the time, you're going to be in a situation where you already have an active span because your framework instrumentation has set that up. And if you're not in that situation, you actually want to move it to that situation. I don't actually recommend creating a bunch of spans in your application code because it's just going to kind of dirty it up. You want to find a way to move that span management out to some kind of manager of some point. So usually there's some place in your framework or your model code or something like that where you can sort of standardize this stuff. But assuming you're in the regular situation of you're just in like an HTTP handler or a model or anything that's happening inside of your framework, you'll automatically have a span available. And so you just grab the OpenTelemetry API, grab the span object, and then ask for the current span. And this will give you back the span, and you can start setting attributes on it. So in this case, I want to add a route name. So this is my Hello World app. This is my Hello World endpoint. So I'm going to name this route Hello. And since this isn't a framework that automatically knows about routes, I'm going to add it by hand. So the key I'm using here is HTTP route. And that's actually a standardized key. So, and Zoom, you're covering up all my stuff. So OpenTelemetry comes with a bunch of what we call semantic conventions. And these are just common, for common operations, just defining what the keys for those attributes should be and what the values should look like. And by standardizing this stuff, we're allowing backends to actually understand the meaning of the data coming in. So if you start writing instrumentation and you're recording something that's common, like an HTTP request or things like that, I recommend looking at these semantic conventions and using them rather than making up your own names, because your backend will be able to understand the information better. But you're also going to have things like project ID and stuff like that that don't have any information or understanding outside of your particular application. So you can just make those up. And you can chain this stuff. So you can just say span.current and then set a bunch of attributes. In addition to setting attributes, you're going to want to record exceptions when they happen. And so there's a record exception method that will automatically format that exception as an event. And then you also might want to change the status of the span to error. And the reason why this doesn't happen automatically with recording an exception is because not all exceptions result in the operation failing. So if you've handled an exception successfully, you might still want to record it, but you might not want that span to be marked as an error and cause an alert to go off and count against your error budget. Likewise, you might be in situations where you're not recording an exception, but you do know an error has occurred. And so setting the span status to error is what gives you these notices in Lightstep. See if we can find some. Right, so they kind of hop out at you, right? And in Java, uncaught exceptions will automatically be added to the span and set an error. So that's how you can find these guys. So that's all pretty straightforward. So setting attributes, recording exceptions, setting the status to error. And then the last bit is structured logging. So there's a method called add event. Add event takes a message name, and then it takes a set of attributes. So this is just basic structured logging. Each event is a log with the name and then a set of key value pairs that can be attached to it. And that is literally it as far as decorating spans with OpenTelemetry. So you really just need to, for the most part, if your framework's automatically managing your spans for you, it's just these method calls that you need to learn. Setting attributes, recording exceptions, setting statuses, and adding events. And that's it. And you can take this code. It's pretty well documented and crib from it if you, just to get a feeling of this working. I do want to show you real quick how you actually create child spans, because that is a thing you might want to get into. If you have a sub operation where you want to get the timing information off of just that particular chunk of code, you're going to want to create a span that wraps that particular operation. So here's how you do that. What you're going to need to do is first have access to a tracer. The way you do that is you access the global OpenTelemetry object. So this is just like an API facade that has a bunch of handy methods on it. I think you can even get the current span from this. And in your class, you just want to create a tracer by calling getTracer, and getTracer takes a name. This is helpful because this tells you what subsystem was actually generating these spans. So just looking up here again, I can see there is an error here, and I can see that this came from this particular class. And then I can look up all the spans that were generated from this class. So you just want to name your tracer after the package, basically, that it was in. So that gives you a tracer. And once you have a tracer, you can start building a span. So the tracer has a span builder. The only required attribute is the name of the span. And when you start that span, it will automatically become the child of the current active span if there is one. You can also manually set child-parent relationships with span, but by default, it just gets added into your current trace as the child of the current span. So now we have a span started. So that's going to start the timer. That's going to measure the length of your operation. And the next step you're going to want to do is make that child span itself current, so that when you call span.current, you're getting this child span instead of its parent. And so the way you do that is by calling make current. And within this try block now, that span will be current. So you need to then, so basically whatever operation you want to record, you're going to put inside of this try block. Then in your finally block, you always want to end that span. If you start a span and never end it, then you're going to create a link. Spans are the one piece of stateful information in OpenTelemetry. So that's one gotcha you need to be aware of. You can also do all of that with an annotation. So if you're just trying to trace a particular method, you can use the withSpan annotation, and that'll do all of that work I was just showing you with way less code. So withSpan is exactly the same thing that we're doing here. It'll create a child span, set it as current, and then wrap the method call. And that is literally it for OpenTelemetry tracing. That's all you need to know. So OpenTelemetry might look like a really big project with a lot of moving parts, But to just get started in Java, you just need to add the Java agent and then know these like 5 method calls to add information into your application. Okay. Now I'm going to switch back to taking questions because I'm sure there were some for this section. And if you want to ask, I'm going to go through the written questions first, but feel free to raise your hand if you want to ask a question. So in the Explorer view in Lightstep, can you filter to, oh, already answered that one. Do the get tracer start span methods have a test double unit test mode that will return stubs that don't actually reach out to the tracing system? Yes, yes. There is. This is why the API is separate from the SDK, because you can have multiple implementations of the SDK. So there are a couple that exist. One is the default implementation is a no-op, and that comes with the API. There is also a mock tracer that's available for doing testing. And you can see that if you go hunting around in OpenTelemetry Java. So let me just try. Well, I won't be able to find it super quick, but if you do look in here, there is a mock tracer you can use. And if you look at the OpenTelemetry test itself, you can see that they're using that mock tracer. So that's the thing you can use when you're writing tests in order to test that your instrumentation is producing the data that you want. So hopefully that answers your question, Mark. Any other questions about the code? We're coming up to the end of our time block, but I'm definitely willing to go over a bit to talk about getting started. So why don't I move on to that right now? Because I know people did have some questions about that. And we can do some Q&A after that. I don't have a hard stop, but I understand if you do have to jump off the call. So let's go back to some best practices. One thing is with spans, you might have a question of like, how many spans should I create? Like, you know, should every method be a span? Like, should I be doing with span, like literally everywhere? And I just want to clarify the answer to that is no. You don't want a one-to-one relationship between spans and functions. Even though that might seem useful, that creates a lot of overhead, and you're not going to really need all of those spans in order to pinpoint where something's going wrong in your system. So I do recommend keeping the spans coarse-grained, just having, you know, one for every major component in your system. So a span for your controller, a span for your model operation, a span for your database request, things like that. And then to use attributes and events in particular to get more fine-grained information. So I just want to clarify that because sometimes people think they want to have a whole bunch of little spans, and that's not actually useful. So the other thing I want to stress is like, how do you actually get started with OpenTelemetry in your organization, right? We've covered how to add the Java agent to your application, but because distributed tracing only really provides value if it's installed in every service in your system, you do want to roll it out deployment-wide. I mean, I shouldn't say it provides no value. You can see from the Spring example that you're getting information about your Spring app. But in order to get the distributed part of distributed tracing going, you know, all of your services need to have OpenTelemetry installed. So to do that, you need to convince your different teams to get that going. And if you've got like centralized like ops or infrastructure team, or your deployment stuff is centralized enough that you can just have one place where you change your configuration to add this agent, then that might be very easy to get it deployed everywhere. But some organizations have like the teams are more like individual cells. and you may have to go to every team and convince them to add OpenTelemetry. And that might be a lot of work. So what I recommend doing in those situations, rather than trying to totally boil the ocean, is to just pick a particular transaction that has a lot of value. So it might be the checkout transaction. It might be something that already has latency or errors or some problem that you'd like to investigate. But pick a particular transaction that has a lot of value. And then identify just the services that are involved in that particular transaction, and just try to get OpenTelemetry added to those services for the purpose of getting information about that particular transaction. So someone asked earlier, how do you kind of help sell this to, your manager, your teammates? Having a particular goal in mind helps that. It makes it easier to go to another team and be like, hey, I'm trying to investigate this. Could you add this agent so that I can do that? You don't need, when you get started, to go in and add a lot of fine-grained information and like heavily instrument your systems. I recommend just trying to get the out-of-the-box automatic instrumentation installed in enough services that you can get a complete trace of a useful transaction. And once you do that, you can then look at that transaction and start explaining the value proposition to people because it's contextualized by something useful that everyone can agree on. And so once you've got that working, you can then kind of expand from there. So you might want to start adding details into your trace, right? There might be application logic or other parts that are under instrumented by the default stuff. And that's when you can start using manual instrumentation. I still recommend trying to package up that manual instrumentation rather than just sprinkle it around everywhere in your app code. If you're using a framework that has lifecycle hooks and things like that, or interceptors, there's usually a way to, kind of centralize some of that stuff so that it's not totally getting in your code. But at the end of the day, it's sort of just like adding logs to your code. It doesn't really take up that much space. But in general, helper functions or anything, creating your own annotations, it's generally useful to kind of wrap things up like that, just to reduce the kind of code bloat when you're looking at your code. You don't want to have it just be a whole bunch of observability code, because that's kind of annoying. There are some common pitfalls. This is the way that I do see it not work, which is someone wants to champion tracing and they go around asking people to add it, but because there isn't a goal, the instrumentation gets added kind of inconsistently, and then you don't have complete traces, so it's hard to show the value of tracing, and then it kind of peters out. So that's why I really recommend if you don't have a centralized place to just add OpenTelemetry easily, you come up with a goal or target that people can agree has some value, and use that as your framing for adding it to particular services. It just makes it easier and more straightforward. And again, because we're talking about things across multiple teams, potentially, that might mean some project management is involved. So as an engineer, you might want to grab a friendly like engineering manager or project manager of some kind and convince them to help you roll it out following one of these plans, rather than just trying to do it yourself as an engineer. And then of course, creating documentation, helper functions and stuff, standardizing your own internal conventions, just making it easier for your teammates to get started with it. So it's pretty common to create, say, your own helper library that kind of wraps up OpenTelemetry stuff and presents it in a way that is maybe more custom tailored to your particular organization. That can be helpful as well. And certainly documenting, we try to provide a bunch of documentation to help with this, but you might have, system-specific documentation that you want to give people. So all of those things are really useful. Okay, let's switch to questions. Oh, actually, one more thing. I was told to let people know about this. If you do actually want help getting started with OpenTelemetry, Lightstep is offering like a consulting gig. This is totally separate from buying the Lightstep product. This is just if you'd like to pay us to just come into your organization and get hands-on with you and help you set OpenTelemetry up. We're happy to do that. Obviously, it costs some money, but that's a potentially useful way to kind of bootstrap this. So if you feel like you need more hands-on help getting started, that is a service we're offering right now. Support at lightstep.com if you're interested in that. So just FYI about that. Okay, now I'm going to get to Q&A. We are a bit over time, but I am happy to stay here and answer questions till we're done. So let me see, where did I leave off here? Rubiner says, I joined late, so I may have missed the part where you mentioned how to get the presentation and links. Yes, here, one last time, let me give you this stuff. So here is the presentation. And here is the code repository. So those two links will do you good. And you will get an email after this with a link to the recording. It's going to go up on YouTube. So if you missed something, you can go rewatch it there. Okay, AA Fischler writes, you were saying the launcher keeps the config part that allows the instrumentation to connect to a specific backend. But isn't that part handled in the collector? Yes, totally. So if you're using collectors, you don't necessarily need to use the Lightstep launchers. You can use the default OpenTelemetry agent or OpenTelemetry clients. And then in your collector, you just add the, we have docs for that, but you just add your access code or your access token and set the endpoint to point at Lightstep. So it's like a 2-line configuration in the collector. So that's another way to do it. The launchers are just so that you can get started without having to spin up a collector. But I do recommend using the collectors. And then if you do switch to that, you don't necessarily need to use the launchers. So you can continue to use them as well because Lightstep doesn't really do much configuration there. You just use the collector and then point the launcher at the collector endpoint. So Mark writes, it seems all the telemetry data is collected from application code. Are there plans for the infrastructure components, databases, caches, web servers, load balance, etc., to add OpenTelemetry support? Yes, totally. Prior to OpenTelemetry, I was working on a project called OpenTracing, which is like the predecessor to this project. And we've added OpenTracing support to a lot of components. And a lot of that is now switching over to OpenTelemetry support. So you should be able to find support for proxies like Envoy for sure has this. Nginx we have support for. And a lot of the databases and caches and things like that, there's currently support for the clients. But when OpenTelemetry stabilizes more, I am excited about actual databases themselves becoming instrumented with this stuff. So I have talked to a number of companies that make this, make databases, and a number of them are excited about this so that your traces can continue on from your application into the database itself. And that might allow you to get more information out than you could get out of just the client. So I know MongoDB did a spike of this a while back, for example, and found that they could instrument all of MongoDB with OpenTelemetry and get a lot of really interesting information. But I think OpenTelemetry, it's just the tracing portion is just coming out of beta at this point. So it's just a little too soon, I think, for those kinds of services to bake it in. But uh, I expect to see more of that support in the future. And for open source projects, it might be a good time to start going to them and asking for OpenTelemetry support. But Nginx and Envoy for sure have it at this point. Sudeep asks, are there nuances around using OpenTelemetry in multi-threaded code? Not too many nuances, except when your work switches threads. So if you're executing work on one thread and then it moves to another thread, you need to actually move the span along with it. That usually happens automatically by just using wrapped instrumented versions of your usual stuff. So, you know, if you're using runners or other like executable objects, thread pools and things like that, OpenTelemetry comes with instrumentation for all of that stuff, and that handles the thread switching for you. But if you're doing like some manual thread switching or something that's not using the kind of standard Java objects for doing that kind of stuff, you may need to write your own wrapper, in which case I would recommend maybe looking at some of the existing code to do that. But generally, I would say like you're probably not going to have to deal with that. So Mark asks, what does the trace timeline look like when there are asynchronous operations like publishing events into a message queue and continuing your own synchronous processing? Yeah, so for basic asynchronous stuff, you'll just see gaps in your traces, right? So the way that tends to work is you will have a child span that then gets injected into something that stores it, like a message queue. So for example, Kafka, you would inject your trace into the Kafka metadata, and there's a Kafka plugin that does this for you. And then when that message gets pulled off the queue on the other end, you extract that metadata from it and continue your trace. Now, that sounds simple, but the thing about message queues and pub subs and a lot of these other graphs is it's not always totally clear how you want to trace it. For example, if you're processing messages in batches, like is every message itself a trace or a span, or is it like the batch itself something that you're trying to process? If you're doing like a scatter gather thing where you have, say, multiple traces that are coming into one final thing, that's where it gets a little more complicated. And the way you handle those use cases is something called links. So I didn't go over it in the code, but there's an additional span builder attribute called links. And what that allows you to do is link spans to other spans. So those other spans might be in other traces, and you can then build a graph of multiple traces. So you tend to use a single trace maps to a synchronous portion of a transaction, and then you use links to link those different synchronous portions together. But that is sort of like, I would say, the state of OpenTelemetry right now. While links do work, I feel like backends probably don't have a lot of support for links yet. So it's actually, that's kind of on my agenda for this next quarter, is to dig into message queues and other topologies beyond synchronous transactions and come up with some better standards for how those should be graphed. So you can do it, but it's not something that I think is super supported yet. but it is simple enough to just use, I think there's instrumentation for Kafka, MQP, and other standard message queue systems. And they just give you a trace, and you'll just see that there's gaps in that trace where it was sitting in the queue. Cool beans. Okay, I think that was all the questions. If anyone has any questions they want to ask, you can use the raise your hand feature, and I can unmute you. And I'll wait a couple more minutes for some more questions to come in. Otherwise, I appreciate y'all for going along with me. Cool. Hey, thank you. Thank you very much. Yeah, so I think we're at the end here. So just last but not least, you know, my little cheat sheet. If you want further help, we run a Discord server. So you can totally find us. Whoop, here, let me get you the link. So you can find more just help and chatting in that Discord server. Austin, the other DevRel here, is usually hanging out. He can answer some questions. I hang out on Twitter, so you can also kind of follow me there. And I don't really post much except for OpenTelemetry related stuff. So it's a pretty lightweight Twitter feed to follow. And I am like starting up like a long running series of blog posts around using OpenTelemetry in different languages and things like that. So if you want to keep up to date with that stuff, you can check me out on Twitter. And last but not least, I'm about to overhaul these docs as well, but we do also have OpenTelemetry docs. So I'm about to, they're sort of in like a beta stage right now. So we're gonna overhaul these, but just to let you know, in addition to the OpenTelemetry docs that you can get off of OpenTelemetry.io, got some that we maintain here. And then of course, I keep that Java Basics repo up to date. So that's a good cheat sheet to follow. So that's the workshop. Hope you enjoyed it. If you have any feedback, feel free to send it my way. You can DM me on Twitter. And otherwise, have a good day. Appreciate it.